So here is question number 26. If n plates are arranged in series as shown in figure, the alternate plates are placed at a distance d and 2d. If n is an odd number, then charge supplied by the battery of voltage V when switch at S is closed will be what, given that plate area is capital A. Clearly mentioned in the question that n plates are there. So how many combinations will be formed? n-1 combination means n-1 capacitance will be there. Total of n-1 capacitors will be there, out of which n-1 by 2 capacitors has plate separation D and n-1 by 2 capacitors have plate separation 2D. Now, first of all, we will solve them one by one. The combination of them will be suppose C1. The combination of 2D separation is suppose C2. Now, first of all, let us find out C1 and C2. C1 will be given as epsilon naught A divided by D times the total number of capacitors are n-1 by 2. That will be C1. After solving, we get 2 epsilon naught A divided by D times n-1. The equivalent capacitance of all the capacitors having plate separation 2D will be C2. And that will be given as epsilon naught A 2D times n-1 divided by 2, where n-1 is the total number of capacitors and they are in series. That's why we are applying this much formula. Means suppose you are having n capacitors, each having capacitance as C in series. So equivalent will be what? C by n. So we are doing the same right here. This gives us C2 equals epsilon naught A divided by D times n-1. Now all the combination are reduced to only 2 capacitors, that is C1 and C2 are in series. So now finally C equivalent of C1 C2 we can write C1 C2 upon C1 plus C2 as they are in series. Solving them, C1 is 2 epsilon naught A upon Dn-1 into C2 is epsilon naught A upon Dn-1 whole divided by. We add them C1 and C2 directly, we will get what? 3 times epsilon naught A D times n-1. Epsilon naught A upon Dn-1, epsilon naught A upon Dn-1 cancel out. Ultimately, we have got the value of equivalent capacitance, that is 2 epsilon naught A upon 3 Dn-1. This is total capacitance we have got, and we know that charge Q equals CV. So therefore, total charge Q will be 2 epsilon naught A upon 3 Dn-1 multiplied by potential difference V. After looking at the option, we can say that option number 1 is absolutely correct. And this is the final expression for charge, that is 2 epsilon naught AV upon 3 Dn-1. Now let us proceed to the next question, that is question number 27. Here is question number 27. The current flowing through the ideal emitter in the circuit will be what? Now, if we see the current distribution, we can say that here the junction will not be there and the wire will become something like this. The equivalent circuit we can write now is 4 volt having internal resistance 0.4 ohm, and the circuit will reduce now something like 8 and 8 right here. 8 and 8 right here. One more 4 is this. So 4, 8, 8, 8, 8, 4. 8 and 8 will have combination 16. And 16 parallel combination of 16 and 4 will give us 3.2. So we will get the parallel combination, that is 3.2 right here, means from them it gets you 3.2 ohm, and the same is below, that is 3.2 ohm, which is connected with a battery of internal resistance 0.4 ohm and EMF 4 volt. 3.2, 3.2, they will have combination 1.6 ohm because they are in parallel. 1.6 ohm is in series with 0.4, so ultimately 2 ohm resistance, 4 volt EMF, and the total current will be given by 2 ampere. After looking at the option, we can say that option number 1 is absolutely correct, so we will go with option number 1. Now let us proceed to the next question, that is question number 28. Here is question number 28. 360 watt 120 volt bulb are connected across 120 volt source as shown in figure. The total power dissipation in 3 bulbs will be what? Total power dissipation will given by P equals dissipation in A plus dissipation in B plus dissipation in C. Now first of all, let us calculate the resistances of the bulb by relation P equals V square by R. Therefore, R equals V square by P. R will be V square, that is 120 into 120 divided by 60. The resistance of each bulb we will get 240 ohm, and calculating the current 240 will form 120 plus 240, that is 360. So the total current drawn from the battery will be what? 1 by 3 ampere. 1 by 3 ampere current will drawn from the battery. Here they will distribute equally as resistances are equal, 1 by 6 ampere. So now we can calculate the power dissipation individually. Power dissipation in A, I square into R. I is 1 by 3, so 1 by 3 square multiplied by resistance 240 plus in PB 1 by 6 is the current, so 1 by 6 square into resistance, that is again 240 plus in PC current is 1 by 6 square, resistance is 240. Solving it, we will get P equals, taking LCM as 36, we get 960 plus 480, which will be 40 watt finally. So this is our final answer, and we can say that option number 2 is absolutely correct. So we'll go with option number 2 only. Now let us proceed to the next question, that is question number 29. So here is question number 29. The magnetic field at the center of tightly wound spiral coil with inner radius capital R and outer radius 4.5 capital R with number of turns 22 when current I is flowing through it will be what? First of all, we know that the magnetic field at the center of tightly wound spiral coil that is something like this. Suppose this is the center of coil, inner radius is suppose A and outer radius it's suppose B. Then the expression will be given as B equals mu naught capital Ni upon 2 times B minus A ln natural log B by A. So this is the expression for magnetic field at the center of tightly wound spiral coil. Here in our expression everything is given. So plugging all the data from question into the expression, we will get B equals mu naught, N is 22, I as it is we have to put 2 times. Outer radius 4.5 R, inner is R. So 3.5 R we will obtain right here, multiplied by ln. B is 4.5 R, A is R. So you will get just 4.5 only. Mu naught into 22 into I, 2 into 3.5, that is 7R ln 4.5. This is the final expression we have got. Now after looking at the option, we can say that option number 2 is absolutely correct. So we will go with option number 2 only, which is absolutely correct. Now let us proceed to the next question, that is question number 30. So here is question number 30. Students, a wire carrying current I is bent as shown in figure and placed in the plane of uniform magnetic field B. The magnitude of magnetic force experienced by wire will be what? Now wire is bent in the form of this type of structure, and the magnetic force due to current carrying wire is given by the expression I L effective B sine theta, where theta is the angle between magnetic field and L effective. Here L effective will be this much. This is our L effective. This is magnetic field. Angle is 45 degree. So we directly can write now F equals current I as I given. L effective will be what? This length. Here it is R, here it is R. So L effective we can directly write using Pythagoras theorem, that is R under root 2. So I R under root 2 multiplied by B multiplied by sine 45 degree. I R under root 2 magnetic field B. Sine 45 gets you 1 upon root 2. Root 2 cancel out. The force magnitude you have got I R B finally. And after looking at the expression, we can say that option number 3 is absolutely correct. So we will go with option number 3 only. Now let us proceed to the next question.